We'd like to invite Enduralock to the stage.
Good morning, everybody. I'm Dr. Harold Hess, CEO of Enduralock. First, I would like to thank the NASA iTech team for their hard work in the last few days in putting this on, and to the panel of judges that are participating. As a mature industry, the fastener industry has not seen innovation in decades. That is changing with the introduction of Enduralock's disruptive fastener technology. For the first time, a permanently locking bolt that yet is reversible and reusable. One often doesn't think about it, but to manufacture all of these items requires millions of these. If you look at the global market, it's actually 83 billion, expected to rise to 130 billion. Aerospace represents about 5.5 billion, expected to rise to about 7.7 by 2021. The two market segments that I included as well are particularly relevant for Enduralock: pipelines and armor attachment, and I'll explain why later. My background, I'm a practicing, or was a practicing neurosurgeon. So in my wildest dreams, I never thought I'd be selling nuts and bolts or standing in front of this audience. But starting in 2007, I invented a spinal implant that eventually received both a CE mark as well as FDA approval. FDA required that it survive 5 million cycles of compression and 5 million of torque without loosening. So I had to come up with a lock. And I realized that this locking technology could have many other industrial applications. So I kept the intellectual property separate, licensed it back to the spine company, and then put the IP into Enduralock. Just as in spinal implants, an aerospace fastener, for example, must be reliable, held securely in place, and above all else, resist vibration. Vibration-resistant fasteners have existed for years, but there are some problems with the current solutions. Enduralock has many attributes, but a key attribute is that it reduces the time and cost of installation and in maintenance. If one looks at a huck bolt, it is a permanent fastener, but it requires specialized tooling to apply and needs to be cut out or drilled out to be removed. And it's one-time use. It also cannot be retensioned should you get bolt elongation. Safety wire, very labor-intensive, therefore expensive. Castle nuts and cotter pins have the disadvantage of only providing for 6 gradations of torque per revolution. In a critical application, such as, for example, on the landing gear of an F-35, the engineers will spec a very narrow range of torque because they want a certain preload. Well, when the mechanic goes to install it, if the slots of the nut don't line up with the pre-drilled hole, they take the nut off and they try another nut. And they'll keep repeating that process until they find a little variance in the nut and things line up. Well, with Enduralock, it's a simple, off-the-shelf 6-point socket to apply it and to remove it. And we can offer over 50 gradations of torque per revolution, and we can also retension the fastener. On our Radiolock fastener, we have 2 machine flats on the bolt that go down to the root of the thread, and the same on the washer. This prevents rotation of the washer. We have circumferential teeth along the rim of the washer. We have a metal spring that has arms that snap onto the nut, teeth at the base. So when these components mesh, the nut can no longer rotate because the washer can't rotate. But when a standard 6-point socket is applied, it flexes the arms inward, disengages the teeth, and now the nut is totally free spinning. Because of that, we can then achieve an accurate preload or clamping force. As soon as the socket is removed, the arms flex outward, engaging the teeth. The nut is now permanently locked. But this same socket can be reapplied to remove the nut, perform whatever maintenance, and then reapply the nut. In aerospace, the requirement for a self-locking nut is to withstand 30,000 cycles of vibration. In an independent test lab, we took ours up to 300,000. We then did tensile testing on the fatigue parts. They proved that to be a Type 1 bolt Class 2 nut. We have cycled the product on and off 250 times. Because of the height of the washer, the teeth remain engaged in a critical application even if the bolt elongates and the joint is loose. We've taken the same technology and put it into the head of a threaded bolt to provide for a locking threaded bolt. There is no competing product that provides for high vibration resistance, even with loss of preload, with easy reversibility and reusability in a harsh environment. If one looks at variability in preload, bolt to bolt, on the one end of the spectrum, you have a Huck bolt. They claim about a 5% variance. On the other end, a prevailing torque, it ranges between 30 and 40% variance. We came in at 5.7. So we have all the advantages of a permanent fastener such as a Huck, with the additional advantages of reversibility and reusability. Over the last 8 months, we have also designed fasteners that can employ a forging and stamping process. The reason that's so important is it dramatically reduces the cost of goods and will allow us to enter industries where cost is more an issue, such as automotive. In our TIDAL fastener, we have a two-piece washer. The arms of the washer have teeth facing inward. They interface with the teeth of the serrated gear, which in turn is keyed into the nut. So when these components all mesh, it's locked. When a standard socket is applied, it flattens the washer, disengages the teeth. We've also taken this technology and put it into the head of a threaded bolt. We eliminated the flats on the bolt. Instead, we have axial tabs on the undersurface of the washer to go into pre-drilled holes to constrain the washer in rotation. With our silver lock fastener, we can stamp the lock member or spring. And with this fastener, again, it functions similar to the animation you saw. When a socket goes on, flexes the arms inward, disengages the teeth. And again, once more, we've applied it to the head of a threaded bolt to provide for a locking bolt. We've also designed a new access panel fastening system that we believe will greatly reduce the chance of foreign object debris. We've designed a nut plate where the nut is actually spring-loaded. With this nut plate, it allows us to establish a fastening system where the bolts are retained with a fixed retaining ring. Currently, the retaining ring floats up and down channels within the bolt. But the problem is those retaining rings can bind and then break and then lead to foreign object debris. With a fixed retaining ring, you don't have the motion, so therefore much less likely to get breakage and foreign object debris. And we can make the retaining ring also much more robust than it's currently used. So when the bolts are all applied and you put the panel back onto the substrate, what it essentially does is it pushes the nuts away from the substrate since they're spring-loaded. And what that allows you to do then is to individually tighten one bolt before moving to the next bolt. Without it being spring-loaded, you would literally have to do quarter turn, quarter turn, quarter turn, all the way around the panel to get the panel off. Here, you can just do the entire bolt, put it on, or when you want to remove the panel, take one individual bolt and loosen it totally. We've gone to great lengths to secure our intellectual property. We have 9 US patents issued and a Canadian patent issued. We are patent pending on 17 others between the US, Canada, Europe, and Japan. About 6 weeks ago, we got a request for a product from Ground Vehicle Systems Center, which is the Army's research center for tanks and ground vehicles. They want to have the bolts and do ballistic testing. The application would be attachment of armor. If one looks at how they currently attach armor, it's a normal bolt, which they have to have a high preload to keep the armor on. But the problem is when you get a blast force, it will want to make the bolt either travel actually inward or want to make it travel radially to the side, depending on the orientation of the blast. But it can't do that. So instead, the bolts shear at the head. A few years ago, the Army did testing where they put the bolts on with less preload. In other words, they were slightly loose. And what they found is they survived the blast. But you can't have loose bolts holding your armor on, because the armor would fall off. But you can with Enduralock, because what we can provide is a locked bolt. So we can have less preload, but it's still locked. And we can also isolate it from the armor and the substructure with Belleville washers. It should survive the blast. Because our fasteners are so unique, we're also moving forward in establishing new national aerospace standards. To create a standard, a company must obtain sponsorship from 2 prime members of the Aerospace Industries Association who commit to using the product once a standard is created. We successfully obtained sponsorship from Bell and Boeing. There are numerous applications in space. If you think about it, a launch vehicle and its payload, such as a satellite, undergoes tremendous vibration. Well, our fasteners were designed for reliability and high vibration resistance in a harsh environment. Gulfstream Aerospace has created their own internal standard and has issued part numbers. They wish to replace castle nuts and cotter pins and some safety wire across their fleet in production and in maintenance. They believe that they will save money. On the energy side, we did 2 joint development projects with Superior Energy for well completions. They plan to commercialize in the next couple months. Halliburton has recently decided to move forward in using our fasteners on their fracking pumps and on their blenders. And about 6 weeks ago, we won a Shell Oil competition. The corporate challenge was how to improve safety through less human interaction in offshore wind farms. I had a meeting with a team of engineers at The Hague, and after the meeting, they decided that it's not just wind farms, but they could use these fasteners across their industry, specifically in pipelines and refineries. So we are currently scaling up the fastener to 3-inch bolts to provide for the first locking bolt for a pipeline, which should reduce oil leakage. We were chosen to be one of the representatives of the US at the Global Entrepreneurship Summit at The Hague. I'm an entrepreneur, but I'm also an inventor. I hold over 60 patents worldwide in my name. Diana runs daily operations, and she established our quality system, which is Aerospace AS9100. Igor comes from Lisi Aerospace, one of the top 3 aerospace fastener companies in the world, where he was Director of Research and Development. We're projecting revenues of approximately $60 million by year 5, with an EBITDA of about 20. We took a very conservative approach, however, looking only at industries where we are currently involved. As our fasteners have applications in numerous other industries, I believe this chart will dramatically change in the next few years. We are currently raising funds. Use of the proceeds will be for further hirees, such as further engineers, sales and marketing, R&D, and intellectual property. Fasteners such as ours have simply never existed until now. Our focus is simple: create innovative, never-before-seen technology that not only meets but far exceeds the needs and wants of our customers. Think about it. Nuts, bolts, washers. They're literally everywhere. So the scalability of Enduralock fasteners in multiple other industrial verticals, I believe, is limitless. Thank you.
Questions from the judges?
Are there any size constraints on your bolts? Or for instance, how small can you make them?
So far, we have modeled down to 3/16. We have actually made 1/4 inch. I believe we actually were working on a project a while back for miniaturizing our design for pedicle screws in the spine. And in that technology, it looked like we could go down to 1/8.
And your vibration resistance, say the external temperature gets real hot or real cold, how do they perform?
We haven't done temperature testing yet, but we can make the fastener out of any material, such for high heat applications, Inconel 718.
How does the locking mechanism, Earl, how does the locking mechanism change as you scale the size of the fastener?
You
Or
can't.
does it change?
Yeah, you can't scale linearly. So what we do is simulations. We use a simulation program by Dassault, and I have a simulations engineer. That's all he does. So we optimize the design for whatever size is required. That's what we're working on right now with the 3-inch bolts.
What's the current head count of your company?
Total of 6. We have 4 engineers, Diana and myself. 2 of them are part-time engineers. One other thing I forgot to mention is we're also working with a consulting group, in a sense, outsourcing sales. And that group, their focus has always been in infrastructure, infrastructure and defense. One of their members is a retired 2-star admiral who was in procurement for the Navy.
Can you give us, since you're outsourcing the manufacturing of these, can you give us an idea if you've looked there, whether or not you've looked into quality control and making sure you have lot-to-lot non-variability?
Right. I mean, we ourselves are AS9100. The firms that we deal with at a minimum are ISO 9001. Most of them are AS9100 as well.
Is this something that you're working on full-time?
Yes.
And then the presentation was really impressive. What are you worried about? Like, you tell a great story. Like, it sounds like you've got a great go-to-market strategy and a lot, and a great product. What are you concerned about?
I really, to be very honest, I don't have that many concerns. I mean, any company always has concerns about
Like, what are your key kind of milestones or things
you know,
you hit over the next year?
theft of intellectual property, I guess, would be the highest on my list.
How to defend that from...
Right. But the interesting thing is, in aerospace, Boeing and Airbus, for example, cannot use a counterfeit part with their knowledge, because literally I could seize the plane when it lands. So if my fastener is on Boeing, I'm not worried about Chinese knockoff or anything of that nature.
Makes sense.
Thanks very much.
All right. Well, thank you. Thanks.